Hi, this is Team 9 for the solar-powered trail cameras. Today, I'm presenting with Michael Baker and Arnold Garcia. My name is Grant Howard. Our outline covers the introduction, background, methodology, results and discussion, our cost analysis, and our conclusion, as well as our references.
So for the introduction, we wanted to calculate the necessary components needed to operate 6 trail cameras on the video mode for 12 hours using solar panels to power the batteries instead of replacing the batteries. This is going to be a complete DC system, meaning that the sun coming into the solar panel is DC, and then our cameras as well are going to be DC. With this, it's going to eliminate the need to replace batteries, which we'll see that later on in the methodology and cost analysis, showing you why this is a better system overall going solar. So trail cameras have been available to the public since the early 2000s. They've been widely used by mainly hunters, wildlife enthusiasts, and researchers to track the progress and the movement of animals without the human interaction being out there in the wilderness with them. This design is great because it can be used to provide power to cameras in dense forest with a canopy not allowing a lot of sunlight in, so our panels can be somewhere outside where the sun is hitting them at all times, and our cameras can be powered by that sun. So here's just the layout, the flow diagram. In the top left here, we have the sun, which is going to produce its rays to the solar panel. It's going to collect that, come to our controller. Our controller is going to enable us to be able to work with the battery to put in the volts and the amp hours that our battery is going to be needed from the battery. Then, of course, it's going to power our 6 trail cameras, and the output will be your video of your wildlife or whatever it is you would like to record.
So in order to calculate our power consumption for our cameras, a given of 0.3 watts was a power consumption of a single camera. Multiplied by 12, we get a watts per hour of 3.6. Multiplied by 6 is the total number of cameras we're using. We get a total power consumption of 21.6 watts hour. Next slide. So with our total power consumption figured out, we could figure out our solar panel sizing using the equation in figure 3. Power needed is 21.6, and solar radiation of Houston, Texas was 4.072 for per day. It was given to us in Global Atlas, and the solar panel efficiency was 15%. The result is a solar panel size of 0.035 meters squared. And our battery size depends on the voltage of the battery and depth discharge and power needed for our system. So our power needed was 21.6. Voltage of the battery is 12 volts, and depth discharge was 50%. Using the equation in figure 3, we were able to get a battery amperage of 3.6. Next slide. So what's the results of that calculations? Our total power consumption of the whole net system is 21.6 watts hours. Solar panel size is 0.035 meters squared, and the specifics for our battery, it has to be 12 volts with a amperage hour of 7. Next slide.
Going over the first part of our cost analysis, we have the solar-powered camera that's hardwire installed directly to the panel. The capital costs labeled in the second column are all of the items that we need explained in our flow diagram in order to make this project operational. The maintenance portion here is what we need monthly over the span of a year in order to wipe down and clean the panels and the cameras. Again, that's only going to be once a month. The equivalent power produced in the solar panel over a year is $125.50, while the maintenance per year covers the cost of replacing the battery every 2 years plus the year's worth of maintenance. Since the battery has a life expectancy of only 2 years, it will have to be interchanged a total of 10 times in the 20-year life expectancy of this project. The grand total in price for the solar setup is just under $6,000. Now we'll compare that to the battery operated trail camera setup. The amount of batteries needed for the camera setup, for each camera takes 8 AA batteries. In total, those packages are going to come out to $56, which the runtime for those cameras, since we're doing video for 12 hours, is going to be just over 1 day, just barely. The yearly cost of doing so is $19,356. Now, factoring in the one-time cost of the camera and the cost of the batteries that's going to be accumulated over 1 year, the fuel cost is going to be the same amount as the batteries, and the cost of the batteries over the 20-year life expectancy of the project is going to accumulate here in the total as $406,218. When we compare the solar powered cameras versus the battery operated cameras, each yearly profit comes out to what our fuel cost is, which it's free for solar, since we don't have to put anything into it besides maintenance, which we subtracted from our fuel cost comparatively, since the batteries is the only part that we have to keep feeding in, and the maintenance is the only part that we have to keep feeding in. We came up with a profit yearly of $19,104. The savings for this project compared over this 20 years is $400,226, and the payback period is explained by the cost amount of the amount of profit that we made off of the camera or the batteries over that 1 year, minus the maintenance required to keep the solar panel trail camera running. Over the first year, we would be able to pay it back in just under 3.5 months.
So to wrap things up here, the system can power a set of 6 trail cameras for 12 hours. Our panel size needed to do so would need to be 0.035 meters squared, with a total power consumption of 21.6 watts. The battery required to do so would be a 12-volt, 7-amp-hour battery. The yearly cost would be $251.50. The lifespan savings would be a little over $400,000. And in doing so, this would keep batteries out of the landfills and contaminating the soil and all the toxicities. So this is overall just a better better for the environment and more eco-friendly. Here's a list of our references that we concluded. And once again, we are Team 9 down here at Houston, and we want to thank you for tuning in.